Okay, welcome to Teens Top Notch Academy. So today we're looking at indices. We have indices and logarithm, but in particular we're looking at indices today. So we have indices. Indices. So indices. So indices is used to represent how many times a number is being multiplied. So instead of us writing a number multiplying itself by so many times, we use indices to represent it. That is in index form. So let's say a is a real number, and a multiplies itself by 5 times. So that a multiply itself by what? 5 times. Let's say a is a real number, and it multiplies itself by 5 times. So for this to be represented in index form, so we will not have it to be we'll have it to be a raised power what? 5. How? A multiplied itself by 5 times. So what we do now is a multiplied by a multiplied by a multiplied by a. So we'll count it 1, 2, 3, 4, 5. And that is the 5 we're seeing here. Do you understand? That is the 5 we're seeing there. So this 5 now it represents how many times a is being multiplied. Do you understand? That is indices. The power here. So this 5 here is called what? Power. We call it power. Either we call it power, we call it also index. It's also called index. Or we also call it what? Exponent. We call it what? Exponent. Power, index, or exponent they're all the same. So they represent how many times a particular number is being multiplied. So whereas this is called the base. This is called the base. So the importance of indices, because someone will ask you, what is the importance of this in your learning? Or if you're teaching somebody, they'll ask you, what is the importance of this in your teaching? So the importance of indices is that it helps reduce a space in which particular number would have occupied. Do you understand? So like if you look at this now, you see that the space this occupied. Okay, let me show you that the space this would have occupied, which is this space here, and the space this would have occupied is larger. It is what? Larger. The space this would have occupied is larger compared to the space this one occupied. This is what? A smaller space. So that is what is called, that is the importance of indices. Indices helps to reduce a space a particular number would have occupied. So let's also look at, let's say a particular number 2, let's say it's a real number as well. So let's call it C, because if we are using A, some persons may be confused and they will be saying that A, that means A is what that always multiply itself. No, that's not what I mean here. A number, it can be 2, it can be 3, it can be 4, it can be any number. So, but let's make use of C here now. Let's say C multiply itself by 3 times. So we have C multiply by what? C multiply by what? C. So this C here now, if we are asked to represent this in its index form, it means you count how many times C appeared, which is 1, 2, 3. So that means we are going to have C raised power what? 3. This is what? Index form. This is the index form of this. And the plural form of what? Index. The plural form of what? Index is what we call indices. So let's write it here that index is the same as what? Indices, whereas index is singular form, and what? Indices is what? Plural form. So this is the plural. This is the singular form of what? This is the plural form of index. This is the singular form of what? Indices. That's just the difference between index and what? Indices. Do you understand? So this is it. So we shall be looking at the laws of indices because there are several laws that govern indices. Do you understand? So there are about 7 different laws that you use or you apply whenever you are solving indices. And with that, you are not going to fail anything. So let's look at the laws of indices. So we have lots of indices. Lots of what? Indices. Lots of indices. Lots of indices. I told you that we have 7 different laws of indices. And this law will have number 1 as multiplication law. Multiplication what? Law. After multiplication law, we have the second one called division law. We have division law. Multiplication law, we have division law, division law. Then we have the next one, which is we have the next one as what? We have power law. Power law. We have number 5, we have zero law. Zeroth law. We have number 6 as we have fractional index law. Fractional index law. Fractional index law. And we have number 7 as what? Product power law. Product what? Power law. Product power law. So these are the 7 laws of indices. 7 laws of what? Indices. We have multiplication law of indices. We have division law of indices. We have power law of indices. We have zeroth law of indices. We have fractional index law of indices. And what? Product law of what? Indices. So we shall be looking at each of these laws today. But in our next class, we will be going into several questions that we are going to that will need us to apply each or some of these laws in solving them. Do you understand? So we have multiplication law. So let's say we pick multiplication law. Multiplication law. So in multiplication law, let's say we have a particular number. So if we have a number raised to a power or raised to an index, let's say we have like 2 numbers, or even if it's more than 2, it's still okay. We have numbers. Let's say we have a, and a is raised to power 3. A is raised to power 3, and it multiplies itself as well. Let's say we have another what? A raised to power what? 2. So we apply multiplication law in solving this. Please, when you have a number, an index, a number in its index form, we have another number in its index form as well. So, and you have a multiplication sign in between them, it means that we are going to apply multiplication law to solve this. Please, if you have two or more numbers, it must not only be 2, it must be 3, 4, or 5, or no matter, maybe depending on how many numbers that is given. So let's say you have a times this, and they are all in their index forms. So it means that you are going to apply multiplication law, but there's no multiplication sign in between them. Don't apply what? Multiplication law. Let's say you have What I mean is this. Let's say we have a raised power 3 plus a raised power what? 2. Please, in this case, you are not going to apply multiplication law. You can only apply multiplication law when it is what? In this form. Provided that there is multiplication sign in between them. Or even you may have something like this, a raised power what? 5. Do you understand? And if there is multiplication sign in between them, then you apply multiplication law. That's the condition. Have condition that there must be multiplication sign in between them. So when we are solving this now, one of the things that you need to consider as well for you to apply multiplication law is the basis. The basis must be what? The same. You know, initially I told you that we have a raised power what? 3. This is called the index, and this is called the what? Base. So the base of this must be the same. So looking at this now, you see that this, and that, they are all what? The same. So if you check the bases, that the bases are the same, so you apply multiplication law. And you also check that these are all what? Multiplication signs. Then you also apply what? Multiplication law. That's the condition that you need to consider. So what do we do now? We now say solution. So solution. So having this now, the multiplication law says that if a number in if numbers in their index forms have the same basis and with multiplication sign demarcating them, so one of the bases is what? Chosen. So we are going to choose one of the base, which is what? A, and the powers are added together. Do you understand? The powers are what? Added together. You choose one of the base and add the powers together. So that means we're going to have 3 plus 2 plus what? 5. Choose one of the base, add the powers together. Choose one of the base, which is A, then the powers are now added together. So that means we are now going to have a raised power what? 3 plus 2 is 5, which is what? A raised power what? 10 as your what? Answer. Do you understand? That's how to solve multiplication law. You must check the base and know whether if the bases are same before you now what? Apply multiplication law. That's it. Okay, let's look at something. Let's look at this. Let's say we are asked to simplify 2 raised power 3, okay, multiply by 2 raised power 2, multiply by what? 2. So we have to simplify this. So if you see something like this, we see equation in this form, you know that you're going to apply multiplication law. Why are you going to apply multiplication law? Why? Because the condition for multiplication law says that the basis of whatever you're given must be what? Same. And if you look at this question now, we have that 2, which are the bases are what? Same. Then the next one says that the powers are going to be what? Added. So that if those bases are same, one of the base will be chosen and powers are going to be what? Added. So it means multiplication law can work in this format. So what to do now is write solution. So first we write given. In mathematics, it's very important. So write given 2 raised power what? 3 multiply by what? 2 raised power what? 2 multiply by what? 2. So I know someone that have not done mathematics before may ask me, please, you said that they must have powers. They must be in their index form. Why is it that 2 is standing alone? 2 does not have any power attached to it. So it means this thing is not going to be applied. No, it must be applied because 2 is already having a power. So we say that a number standing on its own have a power of what? 1. Do you understand? Just like a single person. So a single person has a power of what? 1. That's why you now say the person is 1, or so let's say a pen here. So I cannot say 1 pen. If I say 1 pen is what? Wrong in mathematics. Even in English it's also wrong. So you cannot say 1 pen. You can say a pen or single pen. If I say a pen shows that is what? 1. So in mathematics here now, you cannot say 2 raised power 1. No. You cannot say 2 raised power what? 1. 2 raised power 1 is the same as what? 2. So writing it in this format is what? Wrong. It's wrong for you to write 2 raised power 1. So that's why I wrote 2. Because if you see 2 here, you know that the 2 is already having a power of 1. But the power in this case is what? Invisible. It only takes one who knows mathematics to understand and to see that 1 is there. So for you to have come across this video today, it means you now indicate you know that any number standing on its own is having a power of what? 1. So going ahead to solve this, we have that 2 raised power 3. This is the given question, and based on the law, what we'll do is this and this. Well, we'll choose what? A single base, which is what? 2. If you choose the base, the law still says that multiplication sign is it in between them? You say yes, there's multiplication sign in between them. We have multiplication signs in between them. So we're going to apply the law. So we choose one of the base. You understand? So we choose one of the base. So the next thing you do is to add the powers. So you add the what? Powers. We're having what? 3. You say plus what? 2 plus what? 1. Remember I said there is a invisible 1 here. So that's why you now say plus what? 1. So this is now going to give us 2 raised power what? 3 plus 2 is what? 5 plus 1, 2 raised power what? 6. But that's not where it ends. So if you are solving this in this form, so either you stop here, or if the person that asked you the question wants you to continue, you can say, or you also get 2 raised power 6. Either you punch it in your calculator, or you say you press it what? Or you go by 2 times 2 times 2 times 2 times what? 2. 1, 2, 3, 4, 5 times what? 2. So you say 2 times 2, 4. 4 times 2 is what? 8. 8 times 2 is 16. 16 times 2 is what? 32. 32 times 2 is what? 64. So that means the answer to this is what? 60 what? 64. Do you understand? So in multiplication, positive, in multiplication changes to what? Positive. Do you understand? Multiplication changes to what? Positive. That's what you should know. Multiplication changes to positive. Whereas in division changes to what? Minus. Division changes to what? Minus. These are the things, basic things that you should know about. Do you understand? So we're done with this part. Let's go to division law. I don't want this video to be long, so we'll still have other questions we're going to solve in our next classes. So we don't need to stop ourselves here. Okay. We have division law. Division law. Division law. So in division law, we say if we have a number in its index form dividing another number in its what? Index form, so the divisor is being subtracted from the what? Dividend. Do you understand? The divisor is being subtracted from what? The dividend. Why? This subtraction, because if a dividend is dividing, if you have a divisor and a dividend and a divisor, this sign here changes to what? Minus. That's why it's being subtracted. That's why I wrote this. So let's take an instance that we have, let's say P is a real number, and we have that P is raised to the power of 4. Given that, given, no, given, okay, given that P is a real number and P is raised power 4 and is divided to what? Divided by what? P raised power what? 2. So it has to what? Simplify. It has to what? Simplify. So given that P raised power 4 is divided by what? P raised power 2. Simplify this. So when we're looking at this now, we now know that what we're going to apply here is what? Division law. Because we're already having dividend and what? Divisor. A dividend is this particular number. This is what? A dividend. Okay, let's say solution first. Let's say we have solution. So given, we're given that P raised power 4 is the same as is divided by P raised power 2. So I call this dividend. This is what? The whole of this here is what? Dividend. Whereas this is what? Divisor. So a dividend, a divisor is a number used to divide the dividend. Do you understand? A number used to divide, there is dividend, divisor is always the denominator. When I say this divisor is always what? The denominator. Denominator. Why this one is what? Numerator. So it's always the denominator. Numerator. This is numerator, denominator. So this is the divisor. This is what? The dividend. So we now say that if we have something like this, we're going to apply division law, because we're already having dividend and what? Divisor. But there is a condition here, just as we had condition for multiplication law. We have condition for this. First thing, you check two things. The powers of the dividend and the base of the dividend and the base of the divisor, are they the same? If they are not the same, don't apply this law. If the power of, if the base of the dividend and that of the divisor are the same, so apply what? Division law. And also you check, is there division sign that divides them? Is there division sign that demarcates them? That's one of the things you also check. And yes, in this particular question, we have the base, they are same. And we have what? The division sign in between them. Remember, I said this is P raised power 4. This is what? Index. And this is what? Base. When I mention base, do not forget that base is this P, while index is what? 4. So in this case now, we're going to apply, okay, let me leave it. We're going to apply division law. So what we'll do here now is we have that P raised power 4 all over what? P raised power what? 2. This is the same as, so when you have them like this, collect one of the base, and one of the base, you have this and this. Collect one of the base, and what? If you collect one of the base, you repeat what? 4. So this will now change. So this particular one now will go up to meet this one. So that's why you're already having P raised power 4. You repeated this, P raised power 4. When P raised power 2 is going up to meet P, because P are all same now. So This 4 is just indicating how many times P multiplied itself. So this one is also indicating how many times P multiplied itself, which in this case is 4 times, and in this case it is what? 2 times. So if P now is going to meet this, so this division sign here in between them will change to what? Minus. This is it here. The division sign will change to what? Minus, where we have it will change to minus and it become minus what? 2. The division sign change to minus and it become what? Minus 2. So the answer now will now be what? P raised power what? 2. P raised power what? 2. That is the answer. So let's say we have another question. Let's say we have a question. If we are given 3 raised power 2 all over 3 raised power all over 3. So let's leave it this way. So if you have to simplify this, what do? We check the base. The base are what? The same. So what we do now is to choose one of the base. Then the power here, this is already here. So this going up will now be what? Minus what? 1. No, I told you there is invisible 1 here. So this one now going up will have this. And this will give us final answer as what? 3 raised power what? 1. Because 2 minus 1 is what? 1, which is the same as what? 3. That's the answer. Very simple. Very, very, very simple. So that's just it. So we'll now go to what? Power law. Go to power law. So we'll go to power law. Power law. Power law. You know, when I say power, it indicates multiplication. Do you understand? Indicates multiplication. But in this case now, the power law is always what? The power law is always having brackets. Yes, the power law is always having brackets. So let's say we have a number in this index form, and it has another power. So we'll say it is what? In power law, you are going to apply power law. So it must be in index form. That's one of the things you should note. We have, let's say, we have simplify s raised power 3 all squared. So this is a power law. You are going to apply power law here. So power law must be applied when you have an index being raised to a power. And not just that it's raised to a power, there should be a bracket. Do you understand? There should be a bracket. So you apply power law. So the power law says that the power of the index, so the index or the power of the base in the bracket should be multiplied by whatever is in the outside. So what I mean is this. Solution. What I mean is this solution. So what you do now is to have given, please always remember to write given, or if you are not write given, you can write parameters. Well, it's still the same thing. Given parameters, it's always okay for you to write that. It's part of the solution process in mathematics. So what you do now is we have we're given that s raised power 3 is multiplied by what? 2. And what we do here is what? We'll apply what? Power law of indices. Applying the what? Power applying the power law of what? Indices. Applying the power law of indices. Why the power law of indices say that the power of whatever is inside the bracket or the index of this particular index, the index of this must be what? Multiplied by what? 2, what is outside. So it means that in this case, it means that what we do here is x raised power 3 us squared will now be x raised power what? 3 times what? 2. That's how to solve it. So it's also the same as x raised power what? 6. This is your last answer. 3 times 2 is what? 6. The base will still remain the base. That's how to solve power law. Very simple. Very, very simple. An example is this. An example is this. Let's say we have 2 raised power 3 or raised power what? 2. So solving this now will give us 2 raised power 3 times what? 2, which is same as what? 2 raised power what? 6. And this will be our last answer. If you are asked to represent it or represent your answer in index form, this should be your last answer. But if it's in other way, you now go ahead to give the last answer, which will be I think 64 in this case, if I'm not mistaken. That's it. That is what? Power law. Then we have the next one here as what? Zeroth what? Law. Zeroth law of what? Indices. Zeroth law of what? Indices. Zeroth law of indices. Five zeroth law of indices. Zeroth law. So the zeroth law of indices says that a number raised to a power of 0 or a number having its index as 0 is what? 1. Let's say we have a real number. Let's call A. Let A be a real number. And A is raised to a power of what? 0. Let's say we call it what? Raised by 0. It means that A is what? The answer is what? 1. Any number, whatever number, that is raised to a power of 0 is what? 1. That's what, as simple as that. That's what indices is telling us. That's, let's say we have 100 raised power 0 is what? 1. Any number that is raised to power 0 is 1. We may have 1000. Have 1000 raised power 0 is also 1. Even if you have 1 million raised power 0, 1 million raised power 0 is the same as what? 1. Do you understand? You have 565 raised power 0 is the same as what? 1. So any number that is raised to a power of 0 is considered to be 1. If you punch it on your calculator, you agree with me that whatever number you punch is going to give you what? 1. So, but there is a condition, there's an exception here. There's an exception. I told you that any number that is raised to a power of 0 is 1. Whatever number. But it's not when 0 is raised to a power of 0. It's not when 0 is having an index of 0. No. If 0 is having index of 0, it is not equal to what? 1. If 0 is raised to the power of 0, it's not equal to 1. But apart from 0 being raised to the power of 0, any other number that is raised to the power of 0 is what? 1. So in this case, it is not what? 1. We call it what? It is what? Undefined. It is undefined. Zero can never be raised to a power of zero. It's just like when you're having nothing. So it cannot work out. Cannot work out. Do you understand? But when you're having nothing, it cannot work out. So let's say you have 50 raised power zero. 50 raised power zero is 1. Do you understand? So that is just it. Uh, because of time, I wouldn't like this video. I won't like this tutorial to be long. I won't like this tutorial to be long. So we'll go to the next one. Fractional what? Index law. Fractional index what? Law. Fractional index law. So fractional index law deals with fractions. You know what is fraction? A fraction, when you have something like this, 2 over what? 3. We say it is what? In is what? Fraction form. Where we have 3 different types of fractions. We have what is called proper fraction, improper fraction, and what? Mixed fraction. I'm diverting a bit, but let me just explain what proper fraction, improper fraction, and mixed fraction is all about. So when you have something like this, 2 over 3, we have 3 over 2, and we have one whole number, 2 over what? 3. So this, we call it what? We call this proper fraction. Sorry? Proper what? Fraction. So we call this improper fraction. Improper fraction. Then we call this what? Mixed fraction. So here now, we have that 2 over 3, we call it proper fraction because the numerator is lesser than the denominator. You know, I explained to you before that whatever that is top here, when you're having a fraction, it's called the numerator, and here is called the what? Denominator. So if the numerator is lower than the denominator, we call it what? Proper fraction. But if the numerator is higher than the denominator, it is improper. You know, when something is improper, that the numerator is not supposed to be the numerator is not supposed to be higher than the denominator, so it's improper. That's why we call it what? Improper fraction. So here is mixed fraction. When you're having a whole number before the fraction, we're having a whole number before the fraction, we call it what? Mixed fraction. Do you understand? So this mixed fraction is gotten from improper fraction. Because when you're having 3 over 2, we say it's not supposed to be like that. So it should be one whole number, 1 over what? 2. This is how it's supposed to be written. So instead of us to write it in this form, we now change it to what? A mixed fraction. That means this is dependent on this. So it's we are not having. So how do you do it? 2 times 1 is what? 2 plus what? 1, 3. 3 over 2. That's how mixed fraction came about. So, but that's not what we're treating under this. So I just wanted you to know that this involves fraction. So here we have fractional what? Index. So in this fractional index, let's say we have a real number in this index form. Just as we have a raised power what? 1 over what? 2. And they are asked to simplify this. They are asked to simplify this. So if you are asked to simplify this, okay. If you have to simplify this, so what do? What we do now is This is will represent the what? Square root, the root. It may be square root, it may be cube root, or uh, more than that. So let's say we have this, we have so this will represent the root. We have square root of what? Base. Square root, this represent the root, square root of the what? Base, which is what? A, all raised power what? The what? This, which is the same as what? Square root of what? A, as your answer. Do you understand? So in this form, so we have this. We have a raised power, um, a raised power 1 over what? 3. And he has to simplify this. If you are to simplify a raised power 3, it means that, sorry, let me use a raised power 2 over 3 so you understand it better. So if you have to simplify this, what do you do? What you do now is you write solution. So this here represents the root, the denominator of the power, because this is the base. So we take this as the root, then root of the base, all raised to what? The power. All raised to the numerator of the what? Power of the fraction. So what you do now is you have a root, and here in this case is what? Cube root. So remember, in this case, I did not write square root. No, it's very wrong in mathematics. If you have something like this, it's the same. Something like this, it's the same as what? This. So it's wrong for you to write put 2 here. So that's why I did not put 2 here. So looking at this now, it's already square root, and that's why I did not put that. So but in this case here, you're going to put 3 because you indicate that it is what? Cube root. Cube root of what? A, which is the base, all raised to the power of what? 2. That's how to solve it. And you continue solving till you get the answer. Do you understand? So we'll solve question based on this. We'll solve question. We'll solve question. Let's say we have an example. 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 So we have an example. The example here we have 27. Oh, we have 27 raised power 2 over 3. So if we have this 27 raised power 2 over 3, so how do you solve it? You apply fractional index law because it's already in this format. So what you do is cube root solution given 27 2 over 3. So how do you do this? Now say okay, it's the same thing as this now equals to cube root, take the root of this stands for the root, cube root. Are you seeing what I'm solving? So yeah, you're understanding. I believe you're understanding. But if you don't understand, then you can go to the comment section, then drop all your questions. So I will go and answer you one by one. Please, let's stop. Please, if you have reached this point and you have not subscribed to my channel, please, you are not doing me well. You are not doing me good. Please go to my channel, subscribe, please subscribe. If you are getting value from what I'm showing you, subscribe, hit the notification bell so that YouTube will send it to more people. So like and also share so for others to also get the same value that you're getting. Please, I will be posting other videos, maybe the questions are attached to these examples, very complicated examples. So I'll be solving them. Please make sure you don't miss out. That is the reason why you should hit the notification bell. So whenever I upload any new video, you will get to know about it. You will get to be notified. Please subscribe to my channel. It's very, very important. Subscribe, please. That is what will give me joy to upload more videos and give values to you. So what you do now is going back to this now. This is the root, which is what is here. Then we write our what? 20 what? 7. All raised power of what? 2. So how do we do this? Cube root of 27 is what? 3. Cube root of 27 is what? 3. Or 3. Then raised power what? 2, which is what? 9. So how do I say cube root of 27 is 3? We know that cube root of what? 27 is the same as what? Cube root of 3 times 3 times what? 3. Which is 3 times 3 is 9. 9 times 3 is what? 27. So what you do is collect one of the 3 here, which is this. Then raise power 2, which is what is here. Then give you 9. That's how to solve it. Very simple. Very simple. Okay. So please, I made a mistake here. Sorry. This is not up to 7. Sorry for the mistake. So this should be 3. This should be 4. This should be 5. This should be what? 6. And the seventh one is what? Negative index. Sorry. Let me use red pen to write that. So the 7th one is what? Okay. Don't know if you are seeing it. Let me write it up here. Number 7. Negative index law. Sorry for the mistake, please. Sorry for the mistake. I told you they're up to 7. I didn't notice what I wrote here. So what you do now is to go to product power law. So in product power law, let's say we have different numbers. Let's say real numbers. So of different bases. So raised to a power. That particular power that is being raised is being multiplied, is shared among those bases, is shared among whatever that is inside the bracket. That's how to solve it. It's not hard. So let's just look at an example here. So let's say we have, you are asked to simplify. Let's say you are asked to simplify. Let's say in this case we have s, y, what, z, raised power what, raised power 2. So if you have to simplify, you apply product power law. Why are you applying product power law? Because we're already having this. We have numbers inside the bracket and we're having power here. So what we do, remember, is different from power law. Power law here, there's index. Let's say s squared, y squared. So okay, let's say power law, we have s squared all raised power 2. Where we will now say s raised power 2 plus what? 2, which is what? S raised power 4. So this is not what? This is not product power law. Do you understand? This is not product power law. This is what? Power law itself. This is not product power law. In this product power law, we have different these, and it's not in index form. Are you seeing the difference? They are not in index form. So that's why you need to share the powers among them here. So for you to solve this, we now say solution. Have a solution. So our solution now will be, we are given, what is given? We are given that s, y, and z are all raised power what? 2. And how do you go about this? You solve this by sharing the power among whatever is inside the bracket. So we now have that the answer will now, this now implies that s, y, z all raised power 2 is the same as x squared y squared z what squared. This is the answer. Do you understand? Share whatever, share this power to them. That's it. That's the product power law. That is product power law. Okay. So we also have to solve example on this in our later class. We're going to solve example, but let me just go straight to negative index law now, because there's no time again. There's no time. So negative index law. Negative index law. In negative index law, we have, let's say we have a number, a real number. So we say that the number is taken, the reciprocal of the number is taken. Let's say we have a raised power minus 1. A raised power what? Minus 1. For you to solve this, you have to simplify a raised power minus 1 in indices. So what you do is, you solve this by saying that this is, that implies that, sorry, oh, so this implies that a raised power minus 1 is the same as 1 all over what? A. All raised power what? This, which is the same as what? 1 over what? A. So if you have a question like this, what you do now is, this is the base, and the power here is a negative. Do you understand? So what you do now is, you take the reciprocal of this. No, uh, I told you minus in this case will change to division. So this minus will change to what? Division. Whenever you have minus, let's say you have a, so okay, minus will change to division. So that is the reciprocal, 1 all over, then a, which is the base, all raised to what is here, which is this. That is what is giving you this. Do you understand? So let's say we have another example. Let's say b raised power minus 3. So if you have this, it's the same as, 1 all over b raised power what? 3. How? We have that this is what? This minus is automatically 1 all over. Do you understand? It's automatically what? 1 all over. We call it reciprocal. You are taking inverse. Reciprocal is the same as inverse. You are taking inverse of what is there. You are taking the reciprocal of what is there. So one say 1 all over b, then whatever that is here is what? 3. So this is the answer. 1 over b raised by 3. That's the answer. But had it been 4 is here. So it should be 1 over b raised by what? 4. Do you understand? So that should be the answer. So let me not confuse you. So let's say we solve example. Let's say we solve example. Let's say we solve example. Please, I repeat again, please subscribe to my channel. Subscribe to my channel. Like the video if you are getting value from the video. Please. So let's give an example. It says simplify. Okay. Let it not be that I'm using simplify always. Evaluate evaluate 2 raised power minus what? 3. If you have to evaluate 2 raised power minus 3, you apply negative index law of indices. Why? Because you're already having a base raised to an index, a base raised to a negative what? Index. This is called a negative index. This is what? Negative index. And here is what? The base. You understand? So when you are having a negative index, you apply what? Negative index law of indices. That's why you're applying negative index law of indices, because we're having negative index. But if at it being we're having 2 raised power 3, so you don't, there's no need to apply negative index here, because this itself is what? A positive index, which is the same as what? Index. Do you understand? It's a positive index, which is the same as what? Index. So you can't here, you don't apply the law of negative index law of indices. Do you understand? So moving ahead, if you have something like this, which there is negative index, so if you have something like this, you write solution. Solution. So given 2 raised power what? Minus 3. Applying negative index law of indices. Applying the negative index law, we have applying the negative index law, we have, so this will now be applying the negative index law, we have this 2 raised power minus 2 raised power minus 3 is the same as, so what you do now is this negative will change to 1 all over, then you write the base, which is this base. What is here? 3. So it's the same as this. That is 1 all over 2 times 2 times what? 2. If you don't have your calculator, but if you have your calculator, you just go ahead to press this. Why I'm writing this is because I don't want to make a mistake. So if I know the answer now, I know what is the answer, but I want to simplify so you know how I got it. So what you do now is this is equals to 1 all over what? 2 times 2 is what? 4. 4 times what? 2 is what? 8. That is the answer. So this is where we'll end today. Thank you very much. So if you've not subscribed to my channel, please do well to subscribe to my channel. Like the video if you got value from what I've taught you today, and also go to the comment section, type all your questions, or if you have any observation, you also let me know in the comment section. Please, thank you very much. Do not forget to hit the notification bell so that you will get to be notified whenever I'm going to upload the next video. Maybe how to solve other complex examples that are associated with this particular topic. Thank you very much.